most keynotes are almost instantly forgettable. Very, very few create markets.
The ChatGPT moment for general robotics is just around the corner. What would we use Omniverse and Cosmos to do in the context of self-driving cars? This is NVIDIA's latest AI supercomputer. Let me tell you what I told you. I told you that we are in production with 3 new Blackwells. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI.
Hey everybody, welcome back to the AI Outcomes podcast. And yeah, today I've got something a little bit different for you. And I want to take you through a keynote. Now, most keynotes at conferences, kickoffs, whatever it might be, are almost instantly forgettable. Some are very interesting, and you learn things and you get some insights. Great. Very, very few create markets and paint a picture to those that are listening, really listening, paint a picture of the new reality that is coming with generative AI. Now, AI right now, as I've covered on the podcast, is delivering lots of amazing outcomes. Most people's day-to-day experience using AI is with the large language models, right? They're getting better and better and better. I've covered AI agents. I've covered Klarna getting rid of Salesforce and using generative AI to create their own SaaS systems. I've covered AI in medical, health, phenomenal. Go check out the last podcast. But what is coming is physical AI. It's AI factories, where the AI is thinking and almost having a conversation with itself and producing intelligence and products and generating revenue. And so the purpose of today's podcast is to play for you, and I'm not going to get involved with this. I'll give you my perspective at the end. Play for you NVIDIA's CEO, Jensen Huang, at this year's CES over in Las Vegas, his keynote. Now, at the start of his keynote, he talks about kind of home use for gaming around AI, which is great. Go check that out. But this podcast is for B2B sellers and consultants, right? So the gaming stuff, great, but let's get on to the business side of this, because you need to know this. Your big customers are watching what NVIDIA are announcing here and thinking, how do we get there? How do we enable these types of outcomes? And so when you get to the robotics and autonomous vehicles, that's what Jensen calls physical AI. And it's absolutely mind-blowing. You have to know this. If you're in B2B enterprise sales, you simply have to know this. So I'm going to play it. We're starting about 36 minutes through. Let me jump onto my share here and let's hear from Jensen. I'm going to sit back and prepare to have your mind blown.
One of the most important things that's happening in the world of enterprise is Agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator. And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build agentic AI. NVIDIA NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or TensorRT-LM, or Triton, or all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud, because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company, the business process is different, the way you work is different. So you would give them examples of what the work product should look like, and they would try to generate it, and you would give it feedback, and then you would evaluate them, so on and so forth. And so and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work being done at ServiceNow, at SAP, at Siemens for industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant AI application, next giant AI service, period, is software coding. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's Agentic AI building blocks, NIM pre-trained models, and NEMO framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents, built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nemotron vision language models, Llama Nemotron LLMs, and NEMO Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, They monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here, for every organization.
Okay. That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI is created in the cloud and for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud, it's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have, in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, and artists can quickly realize their vision.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you. Linux is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer, to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge, and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA robotics. So let me give you 3 examples. All right, so the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically it's the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Kion, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have. Through the developers and ecosystem partners, and we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that. This one example that we're doing with Kion and Accenture.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Kion and Accenture are reinventing industrial autonomy.
In the future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers: the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world: Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs. Just so many cool companies, Lucid and Rivian and Xiaomi, and of course, Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate of about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, NVIDIA CUDA, yeah. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers: NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near-infinite variations of the driving scenario. With Cosmos Nemotron video search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. I think the next part is robotics. So Humanoid robots. My friends, the ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots, and Agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.
We're going to have mountains of data to train robots with. NVIDIA Isaac GR00T. NVIDIA Isaac Group. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And, well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Gray CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know, it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like, you know, and you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model, is open, available to activate the world's industries of robotics and such, and three robots working on Agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please.
And thank you to Jensen, his team, his vision, absolutely incredible, and deservedly so. I saw the other day, Jensen is now, I think, the 4th richest person on this planet. He had the vision way back in 2015. He had the vision and he executed, and absolutely incredible. So look, I'm watching that, I'm making notes. So I hope you have been too. And so the other thing to say is, I'm not a technologist, right? I don't understand the granular detail of how Llama works and all these different models and how developers use them and data scientists. I don't understand that, and I don't seek to understand that as a sales professional. I seek to understand the business challenge that the customer has and how this technology can be an enabler to solving that problem. And if I could change the name of sales, I would call it problem solving. Chief problem solver. That's what you should be in sales. And so then you can bring all your specialist resources in as you need to cover the technology elements. But right, why was that groundbreaking? Well, you heard Jensen first talk about AI agents, and at one point he had 9 different AI agents up on the board, up on the screen behind him, didn't he? So it really, really was an eye-opener on AI agents, and he covered off Nemo, which is the digital employee onboarding, training and evaluation system. So digital onboarding, not an actual employee, it's a digital employee. And he talked about this concept of the IT department is going to be like the HR department to onboard, train digital employees, which is another name for AI agents, and then release them out into the business to go do their jobs. I mean, I love it when people who are super smart on technology are also able to simplify and almost put into childlike terms, that you could explain to, an 8-year-old. And that means you really understand the technology, by the way, if you can do that. And so I thought that was incredible. That was one of my takeaways. And so all of that all of that is going to be open source. So he was getting a lot of claps, a lot of cheers at that point as well. NVIDIA not quite got all of their arms around that technology. It is open source. Then he talked about NVIDIA NIMs, which are kind of microservices that you can package up, put in a container, and use across any cloud, any OEM, original equipment manufacturer. So like a technology vendor building compute, all of that, the tech, the tin. And those microservices are going to be focused on a specific narrow area. He mentioned speech, he mentioned vision, he mentioned animation, he mentioned biology. And so you're just going to get a whole bunch of these AI agents. And he also talked about them being NVIDIA providing blueprints for those. Then he went into generative AI on the PCs. Now, he gets into talking about Llama 3, which is Meta's product, and how that's revolutionized AI in the enterprise. He talked about how they're going to platform this on Windows WSL2. So again, if you're in sales and you're selling end user compute, you need to know this terminology, right? So go check out Llama 3.1. Go check it out. What is it? Understand it at a business level and what it does. And check out Windows WSL2 and just some level of understanding around Linux. You're not going to go deep dive on Linux, okay, and how to configure and execute the technology layer. But you need to understand the principles, understand the terminology, so you can talk to your customer about it, right, and ask them about it. Maybe ask them about it rather than get into a deep conversation. Then he moved into robotics. And for me, Jensen using the term physical AI is great. We've gone from digital AI, which is the large language models, the generative AI for images and video, to now we're talking about robotics. And he's talking about, throughout his whole keynote there, he's using the term tokens. And we're going to have to get familiar with what that means. But he's talking about tokens being generated when the task is to take the toast from the toaster, put it on the white plate to the right of the toaster, and spread the butter on it or whatever it was. He's talking about that instruction, that task that needs to be performed, generating tokens that then get fed into the NVIDIA models, that then eventually then get fed into a robot that's going to go and react to the tokens and go and execute the required task. Excuse me. He talked about within the context of their technology, the foundational model for robotics being something called NVIDIA Cosmos. Now, Cosmos is a model designed to understand the physical world. So that might be factories, autonomous driving, for example, hospitals, any physical environment. And that model generates tokens in real time. So that's the tokens piece. So let's get used to when these models are executing. Let's get used to, we may hear increasingly now this term tokens, not may, will. Let's just say will, right? I told you at the start, this keynote is outlining what's coming. You don't need a crystal ball. Just listen to Jensen. He talked about training 20 million hours of video, nature, which included scenes of nature, humans walking around, hands moving, hands manipulating things, getting used to fast camera movements. The training is to teach the AI to understand the physical world. He then moved on to the next point, which is the synthetic generation of physically plausible future scenarios. So what does that mean? Well, it means that you're going to run out of training data. It's just, if you looked at how the training's being done in one instance that they showed on the video there, they showed an operative in the factory and she was wearing the Apple Vision goggles, right? And undergoing her tasks. And of course, the goggles are picking up all of the movements and probably creating tokens that go into the digital twin, and that then goes into the Cosmos, and that then trains it tells the robot what to do. But you're going to run out of that data. Actual collected training data. So Jensen's talking about the concept, and it's the first time I've come across this. As a lay person, it's the first time I've come across this, of synthetic training data. So could the AI go, okay, I can see the types of things that I've been asked to do. I now have an outline and a map of the environment, which is the factory or the hospital, or maybe it's the real world for autonomous driving. I'm going to now create plausible future scenarios. And that gives you infinite amounts of training data, right? Very, very interesting, that concept. It's just crazy when you think about it. Then he talked about things like captioning produced for video. It does that really well. That could be used to train AI models. So you've got all these different data sources. And then, of course, you train it on your own data. Again, he mentioned Cosmos is open, licensed, and available on GitHub. And they want it to do for physical AI what Llama 3 has done for enterprise AI. So you've got essentially 3 computers working interactively all of the time. If your end customer has a factory, they are going to be creating a digital twin of that factory. That is what DGX is. So that's computer number 1. Computer number 2 is the Omniverse with Cosmos. We just talked about Omniverse. That's the real world use of AI to drive the robotics. And then you've got the AGX. And in autonomous vehicles, he termed that Drive AGX. So very, very interesting. So let's just check in on who did he mention. There was a nice kind of case study for a supply chain company called Kion. They're the end customer. Supply chain solutions, their problem that needs solving is their business is completely unpredictable in terms of volumes and what's going to happen globally. Things coming out all the time, black swan events, all that kind of thing. And they're partnering with Accenture and NVIDIA. And what do they do first? They digitized their factory using 3D cameras kind of up high, watching the factory and digitizing it into a 3D model, and that goes into their Omniverse. That then loops into the robot brains, and now Kion can simulate scenarios at scale. So even though their business is completely unpredictable, they now have the capability for when one of those black swan events, like a world issue, Yemen, whatever it might be, stopping all the flow on the Red Sea, whatever it might be over in the Middle East, whatever it might be, typhoons, all the rest of it, their AI has already simulated that scenario. and it can immediately react to it and make the factory, it's not a factory, it's a supply chain environment, warehousing more efficient, more effective in that scenario, right? Really great. Jensen then talked about very similar for autonomous vehicles. And I think that I know a decent amount about autonomous vehicles because I've been very interested in Tesla for the past few years. So in the spirit of openness, I hold a decent proportion of my portfolio is Tesla stock. I didn't buy and hold the Tesla stock because they make nice electric cars today. I bought the Tesla stock and I'm going to hold the Tesla stock for a long time. I'm not a trader, but I look to buy and where is it going to be in kind of 5, 6, 10 years? Because I think they're leading the way on autonomous vehicles. And so I understand, again, at a high level, I understand the autonomous vehicle world more than I understand, say, in a factory environment, just because I've researched it a lot. I've listened to hours and hours of podcasts about it. So Jensen talked about autonomous vehicles being the first multi-trillion-dollar robotics industry. And that's what I already know that. I know that operating a robot in a factory environment is the same principles as operating as an autonomous vehicle, right? You've got the digital world all mapped out. You've got hours and hours of training footage, and then you've got an onboard computer on the autonomous vehicle that's driving the car and doing this onboard inferencing. And so if you look at Tesla, for example, when I first started looking at Tesla, even by 2020, they'd already accumulated 3 billion miles of driving data. Because who knew? Well, Elon and his team knew. They already had the onboard computer in every Tesla they've been selling for the last 7 or 8 years. And that's been capturing all of the driving data. Because if you look at any Tesla, you'll see in the kind of B pillars at the front, at the back, it's got a camera. So I think it's got at least 4 cameras constantly capturing data. And so they were capturing all of the training data because just like Jensen, they knew this was coming. And so they have all of this data. I think now it's driven FSD, a full self-drive now with Teslas. It was only released last year. As now, I think they now have 6 billion miles more of actual real-world driving data. It's probably more than that. But you can see the amount of data, and it almost can have every possible driving scenario that you and I have never encountered. And I've been driving for decades. So, very interesting. Now, on the concept of simulated data, synthetic data for self-driving cars, and simulating that, I would rather, if I was sat in a car and it was driving itself, I would much rather that it had been trained on real-world driving data personally. That would be my personal choice. But there we go. Maybe I'm going to be proved wrong on that. But and I think on a later podcast or an interview I saw with Jensen, he did actually say, look, with self-driving cars, you can't go 100% synthetic data. You have to have a huge amount of real-world driving data. And in my mind, I don't see any other car manufacturer that has that other than Tesla. I could be wrong, but there we go. That's what my research says. Now, they have a computer in the car. It's called Thor. He actually picked up Thor and showed it in his hand. It's kind of like smaller than this controller. And so it's 20x, so 20 times faster and better than the last processor. And just to prove the point, the Thor processor that sits on board the EV, whichever manufacturer it is it's the same processor that sits in the humanoid robot or in the robot that's stationary installed in a automotive factory, for example. It's the same processor. He announced Toyota and NVIDIA partnership to create their next generation of EVs. Everybody's going into the EVs, and they're going to need to be able to drive themselves. And he talked about Drive OS, which is a safety computer. I didn't know about that before either, but you know, if your customer is a car manufacturer, like quadruple down on going to research this stuff, right? And then let's get into humanoid robots and the last portion of his talk there. I guess why humanoid? Well, the world's designed for humanoid robots. If you listen to Elon, you will regularly hear him say that he believes the humanoid robots that are being developed, not just by his company, Tesla have Optimus, lots of other companies. I showed Figure AI robots in my pilot podcast episode, and that Figure AI robot was working in BMW's digital twin factory environment. So go check out my pilot episode and go through the chapter markers if you want to see Figure AI's robot working in BMW's factory. And so the world has been designed for humans to work in factories, for vehicles to be driven by humans around factory environments, for homes are designed for humans, kitchens are designed for humans, washing machines are designed for humans to use, right? And so if you're going to have a humanoid robot in a factory, in a home, domestic environment, in a care home environment, well, kind of needs to be the shape of a human, doesn't it? To use all the stuff that we've created, because we live in a world designed for ourselves. I love this quote. Jensen, the ChatGPT moment for general robots is just around the corner. I think that's coming later this year, 2025. I think just like a few years ago when we first saw ChatGPT, we were like, whoa, holy cow, what's this thing? I think kind of the general public is going to have that about humanoid robots. I don't think most people really understand how good these things are and how fast they're going to get adopted. I'm going to do a video on humanoid robots. I'm fascinated by them. So let's look at critical capability is how to train the humanoid robots, as human demonstrations is laborious to do. So they're going to use AI Omniverse to synthetically generate millions of training tasks. Yeah, makes perfect sense. Once the robot's kind of seen, okay, this is the types of things that we need to do in a factory, in a care home, in a domestic environment, it's not going to be difficult for it to synthetically generate more and more training data and those plausible future scenarios. I love that phrase. So basically, the training data creates your digital twin and then goes into Omniverse for scaling and then into Cosmos that drives the robot. And don't forget the tokens going through. Tokens passed from one system to another, in my most simplistic terms, creates mountains of data to train robots with. DGX, that digital twin, is unbelievably small. That's quite clever what they did. If you're watching on YouTube, you could see the video. They actually had DGX, and he said, well, wouldn't it be great if it was smaller? And DGX, just like on the stage, just gets really small. And then he's, again, able to hold it in his hand. And then it kind of went into a load of technology. And what I've done is, if you're watching, you want to go see that, go watch you'll see the link, go watch Jensen. But I'm just going to take that out of the pod because he went quite deep on granular on technology, which is not where my audience wants to go. And then that was it. And before we got to the AI agents, he was also talking about the launch of Blackwell. So NVIDIA is currently at Hopper, and Blackwell is coming, and that is going to be 30x what Hopper was. So it's going to be really powerful. That launch, when it comes, going to be a very big deal. You're going to see it, no doubt, all over the news, and there's going to be, no doubt, a massive rush is already on to secure as much of those Blackwell systems and processing units as these big organizations possibly can. So there we go. That was, I think, of all the keynotes I've seen in the last 6 months, that's maybe the last year, this is the one to understand if you're in B2B sales. This is the one to understand. You know, I've talked about the concept of, if you're in B2B technology sales right now, there is a wave to catch called AI, and you can ride that wave. Now, 2 things that you need to do to be able to catch a wave, and anyone who's ever been surfing knows this, you need to paddle like mad whenever you're learning to surf. You don't paddle hard enough, do you? And the wave just washes under you and it's gone. And so you learn to paddle as much as you can. Your arms are burning. That's the equivalent for research for B2B technology sellers right now. The paddling, the paddle, that's your research. The second thing you need to do to catch a wave is be positioned correctly. So you need to see the wave. You've seen a few waves come already. Where are you going to catch the wave? Where is it at its steepest? And the positioning for me is about predicting the future. And I think in B2B sales, I think it's about predicting the next 6 months to 1 year. Because AI is moving so quickly, that's all you need to do, right? Just predict the next 6 months to 1 year. And this video is instrumental in helping you be in the right position to catch that wave, which is what I want for you. And I know if you watch this, if you follow this podcast, if you watch these videos, and I'll keep bringing these keynotes to you, whenever I see something that I think, yeah, my audience needs to know this. If you're out in front of customers and you want to be adding value and talking about AI innovation, it's very unlikely you're going to get trained on that in your own organization. Okay, sales enablement doesn't work that quickly. So come to this podcast and I will help you be enabled to handle those early sales stage customer conversations, right? So research, paddle like mad, positioning, when you're lying on that surfboard, waiting for the big wave, you let a few go, don't you? You're looking behind, you're looking behind you. You're looking at the horizon, what's coming. But with AI, it's the very near horizon. And then you see the big AI wave. You're in the right position. And then you paddle like mad and you catch it. And you stay on that wave. Okay, thank you. Longer episode for this week. Again, I've learnt a ton. So please subscribe. I will promise I will bring, it's my commitment to you to bring to you everything that's going to transform your customer conversations around AI. You need to engage now. Great news is we're all still nice and early. Okay, everybody, until next week, you have a great week. Thank you.